Picture this. You come home after a long day, completely unaware that a silent, invisible invasion is already underway. Your sanctuary, and let's be real, probably your largest financial investment, is literally being eaten from the inside out, right under your nose. It sounds like the plot of a horror movie, right? But for millions of homeowners, the threat of wood-destroying insects is a very real, very costly daily reality. Welcome to The Explainer. Today we're stepping into the shoes of forensic investigators. We are going to examine the crime scenes, analyze the physical evidence, and learn exactly how to profile the most destructive culprits hiding in our walls.
It's a terrifying question, isn't it? Honestly, most people wouldn't notice a single thing until a floorboard completely collapses or a door frame crumbles into dust in their hands. But hey, here's the good news. We aren't going in blind, and we absolutely do not have to wait for the structure to be ruined. By using a highly specific, proven methodology, we can actually spot the microscopic clues and subtle behavioral signatures these insects leave behind way before any major damage occurs. We just have to know exactly what to look for.
To do that, we need a solid strategy. So let's open up Section 1, Smarter Defense with IPM. Consider this our official detective's playbook for dealing with these structural suspects.
Okay, let's dive into this. Integrated Pest Management, or IPM. Now, I know it might sound like dry corporate policy, but it's actually a brilliantly proactive, investigative methodology. It's the absolute gold standard for pest control. You see, the goal here isn't just to blindly spray harsh chemicals everywhere. Instead, it's an environmentally sound approach that relies on using the absolute least hazardous techniques to manage pest populations at acceptable levels. Ultimately, we're fundamentally minimizing the risk to people, non-target organisms, and the environment as a whole. It's smart, it's targeted, and it is highly effective.
A really successful IPM program essentially boils down to these key investigators' ingredients. First off, you have to positively identify your pest, because you obviously can't fight an enemy you don't understand, right? You need to set action thresholds, use multiple control tactics, and gain the cooperation of property owners. But as investigators, the absolute most critical part of our inspection is looking for requisites. What's a requisite? Well, it's simply a necessary thing. It's the motive and the opportunity a pest needs to survive in a specific location. Things like food, water, and shelter. If you reduce a pest requisite, you reduce the pest. It really is that simple.
So, now that we have our methodology down, let's move right into Section 2, the primary suspects, termites. These insects belong to the order Isoptera, which literally means equal wings, and they undergo simple metamorphosis. Now, what makes them so incredibly destructive is their ability to digest the cellulose found in wood. But here's the crazy part. They don't do this alone. They actually rely on a complex internal cocktail of single-celled protozoans, bacteria, and special enzymes. In fact, the young nymphs obtain these essential protozoa from the older workers through a process of food sharing called trophallaxis. Basically, they're passing down a microscopic digestive toolkit.
And this brilliantly illustrates one of the most common public misconceptions out there. During mating season, winged termites, which are called swarmers or alates, take to the air. And panic homeowners frequently confuse them with completely harmless flying ants. If you happen to find a winged suspect near a window, you absolutely need to know exactly how to tell them apart. When we place these winged suspects side by side in a forensic lineup, the differences become beautifully clear.
Let's break down the anatomy like we're building a forensic profile. If your suspect is an ant, it's going to have distinctively elbowed antennae, a clearly pinched, narrow waist, and its front wings will be longer than its back wings. But if you're looking at a termite, you'll see straight, beaded antennae, a broad, thick waist, and two pairs of wings that are completely equal in length, which is where that name Isoptera comes from. Memorize these features, and I promise you will never misidentify these two suspects at a crime scene ever again.
Within this termite syndicate, there are some exceptionally bad actors. Look closely at this mugshot. This is the soldier cast of the Formicin subterranean termite. You can easily spot it by its unique teardrop-shaped head. First collected in the US back in the 1950s, these highly destructive invaders have spread like wildfire throughout southern coastal communities. And what's really fascinating is that recycled railroad timbers are a major source of their spread, and they definitely don't travel light. To put it in perspective, a single Formicin colony can boast a staggering population of over 1 million individuals, with a super high percentage of them being these aggressive, teardrop-headed soldiers.
Now, what's really interesting about this is the physical evidence left behind by a completely different faction, drywood termites. Unlike their subterranean cousins, drywood termites require absolutely no contact with the ground. When they infest a home, they leave behind, actually scratch that. It's more like they leave a fingerprint of these unmistakable fecal pellets. They are hard, dry, and have this distinct elongated oval shape with exactly 6 concave sides and rounded ends. The color can vary from creamy to reddish brown to black depending on the exact wood they're eating, but that six-sided shape, it never changes. If you see a pile of these, you have a drywood termite problem, for sure.
Let's quickly break down how moisture acts as the ultimate requisite here. We can neatly categorize our three main termite factions based entirely on their water needs and their gang size. Subterranean termites require constant ground moisture, and they form massive colonies ranging from 50,000 to well over 1 million. Drywood termites, like we just talked about, thrive in wood with less than 15% moisture, forming much smaller, stealthier colonies of under 5,000. And finally, dampwood termites. These are the giants of the group. They aren't subterranean, but they require highly saturated, moist wood to survive.
Transitioning away from termites, let's open the file on Section 3, wood-boring beetles. Belonging to the order Coleoptera, these silent drillers are vastly different from termites because they undergo complete metamorphosis. That means they have distinct egg, larva, pupa, and adult stages. And it's mostly their larvae, often called woodworms, that do the really hidden, insidious damage.
Just like with termites and ants, mistaken identity is a huge issue here. Look closely at these two suspects. On one side, we have a flower beetle, and on the other, a true powder post beetle. To the untrained eye, they look pretty similar. But a trained forensic investigator will immediately spot that the flower beetle has eyes that literally wrap around its head and a very distinctive three-segmented club on its antenna. The true powder post beetle, on the other hand, it has globular, perfectly round eyes and a completely different two-segmented antenna club.
When you're investigating beetle damage, the size of the exit holes and the exact texture of the frass, which is that powdery wood dust they leave behind, tells the entire story. It is a highly tactile crime scene. True powder post beetles leave tiny, round holes up to 1/8 of an inch and a frass that feels incredibly fine and silky, kind of like talcum powder. False powder post beetles leave slightly larger holes and a coarse, tightly packed frass. Anobiid beetles leave elongated, loosely packed frass. And the old house borer? They leave distinctively oval-shaped holes up to 3/8 of an inch with coarse, packed frass. You can literally feel the evidence to identify your culprit.
This brings us to our final suspects. Section 4, carpenter ants, appropriately known in the business as the excavators. These are relatively large, polymorphic insects, meaning the workers come in multiple sizes within a single colony, and they are primarily nocturnal, operating mostly under the cover of darkness.
So, the crucial point is understanding their motive. Unlike termites and beetles, carpenter ants do not eat wood. No way. They simply excavate it to create their nests, hollowing out galleries in trees, stumps, and yes, the structural lumber of our homes. Because they aren't eating the wood, a carpenter ant crime scene looks completely different. Their excavated galleries are incredibly smooth, almost like they've been perfectly sandpapered down, and they are completely free of the mud you'd always see in a subterranean termite tunnel. Plus, because they like to keep their homes clean, they actively eject their frass out of small windows, leaving these little piles of debris that often contain dead insect fragments and pupal cases.
What we have covered a whole lot of ground today, analyzing the motives, requisites, and physical evidence of the insect world's most destructive architects. To wrap up, I want to leave you with a quick pop quiz, pulled straight from the entomological source material we've been exploring. All right, here it is. Which of the following termite species is most likely to be found attacking wood with moisture levels less than 15%? Is it the Formosan termite, the eastern subterranean termite, the desert termite, or the powder post termite, also known as a drywood termite? Think about it. If you answered the powder post or drywood termite, you are absolutely right. You are now officially armed with the forensic knowledge you need to protect your home. But before we go, consider this one final thought. Now that you know exactly what these subtle clues look like, when was the last time you checked your own attic? Keep your eyes open and never let the evidence go unnoticed.